Welcome to the sine rule. So the sine rule is comparing or allowing us to find lengths of sides or angles using for non-right angled triangles. So to find a side length, we have the sides on the top in our formula. So it's little a, which is a side length, over sine of big A, which is the angle, equals little b over sine of big B, equals little c over sine of big C. We don't actually need to label the triangles, but if it helps, that's fine, as long as you match opposite sides to opposite angles when you use your formula. So here's an example. We're going to find the value of x correct to 2 decimal places. So let's label the triangle first, just to show how it works using the formula. So we'll label the triangle using A and B. So they're the first two in the formula. We could have done A and C, B and C, M and N, could have done any combination, but we'll just go with what's here. So little a over sine of big A equals little b over sine of big B. So on the little a side is x, and the angle opposite, so where big A is 80, equals to 7, which is on the little b, over sine of 60. Multiply by the sine 80, and we get x equals to 7.96. So when we find an angle, we just flip everything. So we put the angles on the top. So sine of big A over little a equals sine of big B over little b equals sine of big C over little c. So let's find the sides of the angle U correct to the nearest minute. So once again, we'll label our triangle and we'll then use the formula. So little u is opposite big U and little v is opposite big V. So we're trying to find the size of angle U. So sine big U over little u equals sine big V over little v. That gives us sine of u over 7.3 equals sine 32 over 5.6. Multiply by the 7.3. That gets us about 0.69079. There's a lot more decimal places. And then a reminder, when we're trying to find an angle, we use the sine minus 1, or on your calculator, shift sine, and that gets you 43 degrees and 42 minutes. Thank you.